let f of x be a piecewise function defined by three parts. The first part is 3x squared plus 5x plus 2, and this is if x is less than 1. The second part, 2x squared plus 6x plus 2, if x is greater than 1, and then 12 if x equals to 1. And we want to compute or to find the limit as x approaches 1 of this piecewise function f of x. Now, unlike functions with one piece, you cannot plug in 1 for x into this function, because if you say the limit as x approaches 1 of f of x is equal to f of 1 equals to 12, even though f of 1 is defined, that would be a big mistake. Whenever we're dealing with a piecewise function, and here limit is for x approaching 1, you can see that this function is separated into pieces right around 1. That's where you have to be careful. So instead of doing that, we have to remember how we approach 1. We can approach 1 from the right side. That would give us the right-handed limit. We can also approach 1 from the left side. That's going to give us the left-handed limit. If those limits agree, then the limit is going to be defined. If they don't agree, it's going to be undefined. So in this case, we have to look at the two limits. The limit as x approaches 1 from the left of f of x. Let's compute that first. Now here, the function is defined before 1, left meaning that the values of x are less than 1. It's defined by the first part, which is 3x squared plus 5x plus 2. So now we can put 1 in there for x, and that gives us 3 plus 5, which is 8 plus 2, 10. The left-handed limit is equal to 10. When we look at the right-handed limit, that means we're approaching 1 from the right. We're taking values of x bigger than 1, slightly larger. And the function is defined for those values by the second part, 2x squared plus 6x plus 2. So we put 1 in for x here. We get 2 plus 6 plus 2. That's also 10. So notice that the left-handed limit and the right-handed limit are both equal to 10. That implies that the limit as x approaches 1 of our piecewise function f of x is equal to 10, this common limit. It's not 12. So let me draw a picture of what is happening here so you can see graphically. I'm not going to graph this function precisely, just sort of figure out what's happening right around 1. So here is what this looks like, possibly looks like. Here is 1, and right here is 10, and right over here is 12. So right before, when we approach x from the left side, the function is heading toward 10. It's not actually equal to 10 there, so we're going to put a hole like this, and the function is approaching 10, so it kind of looks like that. Right after 1, when we approach 1 from the right, the function picks up and leaves right at 10 also, so it kind of leaves like this. The value of the function is at 12 right here where I have this point. So remember, the limit is not necessarily the value of the function. The limit simply says, as we approach 1 from either left or right, as the x-coordinate approaches 1 from left or right, what's happening to the y-coordinate. And you can see from the left, the y-coordinate is heading toward this hole whose y-coordinate is 10. Similarly, when we approach x from the right, the graph is heading toward this missing point here whose y-coordinate is 10. That's the limit. So the limit as x approaches 1 of f of x is equal to 10. But this right here, this is the actual value of the function f of 1. That's equal to 12. They do not have to agree with one another. They could be different. Limit is one thing, the value of the function is another.